Hey guys, welcome back to the second video on polynomial review. So what we want to talk about today in the second video is that we're going to be looking at solving polynomial equations and inequalities, both looking at the graph and using the equations and the inequality actual expression that you have. So a little bit of review from the last video is that we saw that solving was fairly easy as long as we could factor the polynomial. So let's look at an example here. So we have the graph of the function. We have a cubic here. So first thing we're going to do is we're going to factor it just like we had done in the previous video. I'm going to look for a GCF first. So I'm going to pull out an x. That leaves me with x squared plus x minus 6. Then we want to go ahead and factor that quadratic. So I'm just going to use the quick guess and check. Because it's a minus and then a plus, a minus for the constant and then a plus for the middle term, I'm going to do a 3 and a 2. I'm going to make the 3 positive and the 2 negative. And just kind of making sure you can always check your factoring by remultiplying it out to make sure that it works. So once we have that, and then it says find the zeros of the function. So we're going to set f of x equal to 0 to find the zeros of the function. And then you're going to set each factor equal to 0. So x equals 0, x plus 3 equals 0, x minus 2 equals 0. So our zeros, I'm just going to go ahead and list them, are going to be 0, -3, and 2. If you just continue your solving on each of those. And so we have those down. And what we learned in the last video is that if we were to look down here, here's the 0. Notice that's one x-intercept. Here's my -3. There's another x-intercept. And 2 is my third x-intercept. So the zeros, when you set your polynomial equal to 0, factor and solve, are going to be the x-intercepts on the graph. So kind of coming over here into this idea of inequalities, we can use these values now to help us. Of course, f of x equals 0 at x equal to, I like to put them in order, -3, 0, and 2. So at the x values, that would be the solution to that equation. Now, for the inequality f of x greater than 0, what we're looking for here is where the graph is above the x-axis. And we've done that before in our pre-calc classes, so it should be fairly straightforward. It's above, in between, let's do this a little yellow, in between these two x-intercepts, and then after that x-intercept for the remainder of the time. So let's just go ahead and we're just going to, I like to emphasize that these are intervals. So I say on the intervals, and we would list them -3 to 0, and we have 2 to infinity on that. Notice that I'm using parentheses in those intervals in the interval notation because I do not want to include the endpoints. So just as a recap, parentheses does not include and brackets include endpoints. And so that is kind of why I'm making that choice. And let me just make sure I kind of zoom out just a little bit for you. When I do f of x less than 0, that's strictly below the x-axis. Maybe let's change to turquoise for that. So that would be this section here and this section there on my graph. So I just write the intervals that correspond to that. So -infinity up to -3 and 2 to, whoops, not 2 to infinity. I got excited there. And 0 to 2. And then just kind of talking about the bracket versus the parentheses, the only thing that changes down here when we go into the greater than or equal to or the less than or equal to is going to be that now you're going to use brackets to include the endpoints. So, and you always know that your infinity cannot be included. You can't equal infinity, so that's always a parentheses. So greater than or equal to 0 becomes bracket -3, 0 bracket, and bracket to infinity parentheses. And then the last one for less than or equal to would be -infinity to -3 bracket and bracket 0 to 2 brackets. And so that's kind of the only change that I made in terms of those and taking a look at it. Now, the next thing that we want to do is kind of make this connection. Right now, we're looking at the graph and using the graph to determine these answers. But what we want to do is we also want to be able to look at this more algebraically, as opposed to looking at it just by looking at the graph. So let's pretend that we do not see the graph at all. Okay, so kind of coming back into this, pretend we're going to start this problem over again. The factored form of it. So you would do the same thing that we did originally. This part right here, this polynomial, I'm going to go ahead and I'm going to factor it. Now, we just did it. We had taken out an x, and then we had our two factors. I'm going to skip the middle steps, x plus 3 and x minus 2 greater than or equal to 0. So we kind of get that over on the side like that. Now, the next part of this algebraically that we're going to look at is we want to set each factor equal to 0 to find the quote unquote zeros of the function. Now, this is going to be something that in calculus, especially, we're going to call critical points. So we're going to take and we're going to set x equal to 0, x plus 3 equal to 0, x minus 2 equal to 0. So our critical points are going to be, critical points are x equal to 0, -3, and 2. And so we find those critical points as our first step. Then we're going to take a number line and we're going to draw a number line and we're going to put those on in order of how they occur. We don't really care so much about the spacing that's there because we're just kind of organizing. This is just an organizer to help us see the signs, right? Remember, this is called a sign chart that we are going to use to figure out where the function is positive or negative. Now, I like to come in here and put zeros above those values. When we do rational functions later, we may put undefined there. But for right now, those are the zeros of the function, so I put those in. Then what we're going to do is we're going to pick test values in each of the intervals. And so for this, we have we have 4 intervals. So here I'm going to test maybe -10. Here I'm going to test maybe -1. Let's test 1 there, and let's test, say, 10 right here. And what I mean by test is you're going to plug this back into the factored form because that's going to be the nicest one. So we're going to plug it back into this factored form up here that I'm highlighting in green. So when I plug -10 in, and we don't care about the value, we just care whether it's positive or negative. So we're going to look at each factor individually. When I plug -10 in, the first factor x is going to be negative. The second factor is also negative, and the third factor is also negative. And if I were to multiply a negative times a negative times a negative, overall, that would be negative. So I'm going to put a minus in the interval from -infinity to -3. We repeat that for -1, so that would be a negative for the first factor, a positive for the second factor, a negative for the third factor. So overall, that one is going to be, I'll put that in blue, positive when we take a look at it. All right, and then we do test our next one. It's a little tedious, but it goes fairly quickly. You don't necessarily have to write everything that I'm writing down when you do these. You can do a lot of it in your head. So I'm going to plug in 1. So that would be positive, positive, negative. So we're back to a negative in that section. And then we plug in our 10, and that would be positive, positive, and positive. So our last section is positive. And we can kind of compare that to the graph that you have above. If I can slide up, do you see where the negatives correspond to where you were below and the positives correspond to where you were above? And so this kind of replaces the graph that we were using to answer the question. So now we can answer the question by referring to the inequality that we were solving. So I'm coming back up here and I'm looking at this inequality and I'm saying, hey, it's greater than or equal to. So I know that when I go to write my solution, I want the choose all the intervals that are positive, and I want to use brackets because of the equals to 0. So that's kind of how I know when I'm going to do my solutions. So the positive intervals would be bracket -3 to 0 and bracket 2 to infinity. And so that would be the solution to the inequality that we started with solving our um, x cubed plus x squared minus 6x greater than or equal to 0. All right, so I've done this example. So what I would like you to do is to take a look at the next example down there. And I would like you to pause the video and I would like you to try that one on your own and come back when you are finished. So I'm just going to count down to 5 and that'll give you time to pause and then come back. So 5, 4, 3, 2, 1. And hopefully now you're ready to start the video and look at the key. All right, coming back in, taking a look at this example, kind of the couple interesting things about it is you can see right here that the square root of 2 and negative square root of 2, not as nice of an answer. When we're doing this, it doesn't really matter that that's a decimal because you can really get basically close enough when we're doing these, especially in the sign chart, knowing that it's one-ish. Square root of 1 is 1, square root of 4 is 2, so square root of 2 falls in between. It's between 1 and 2 is good enough for a lot of what we're doing. Now, taking a look at it, here are your solutions over here. Go ahead and check those with what you found. And then just kind of pointing out down here on the sign chart, when we're looking at this, that kind of as I did it, I found the critical points. The critical points set those factors equal to 0. So that would be that part right there. I determined the signs. I did my test values in the green down here at the bottom. You don't have to show this work. You can do this in your head. That's perfectly fine. You're just trying to determine the correct signs for your sign chart. And again, the purpose of this is what do you do when you can't solve it or you don't have a graph? So this is the sign chart method that we've been practicing before. And in this one, it was looking for a less than. So that meant that you want to use intervals that are negative and you're looking for parentheses on the endpoints. All right, I'm going to stop this video here because what I would like you to do is to go ahead and try the next one on your own. And in the next video, we'll start that up with a discussion of some important things that are something a little different about that one. So I'd like you to try that one on your own and then watch the next video, which will explain a couple of key features about that one that's kind of important for things that are moving forward. All right, I'll see you in the next video.